This is our light seminar, second day. Hello, Reed! You're the first person here. Actually, you're not. Actually, I'm the first person here. Hello, Megan! Hello, Shirley! Hello, Solana! Hello, Harper! Hello. Okay, so suddenly there's many people here flooding in for me to say all of your names. Hello, everybody! That was two hands. That was too many. Two is too many. We're just gonna kind of say that. Hello, everyone. We'll just wait a minute while for other people to get here, and I will, I don't know, just kind of ramble aimlessly into the camera right now. How y'all doing today? I'm doing great. Thank you for asking. You know what? You didn't even ask. You didn't even. Rudeness is what that is. All right, let's start this thing. Hi, everybody. My name is Brandon. We are going to start this thing right now. Welcome to the second day of our Light is Weird class, where we will be asking one simple riddle and finding out, oh, what a weird answer today's is. Honestly, I gotta say, the first day's Light is Weird class, it was good. It went well. I don't know. I think I taught it well. You guys, from the feedback that I got through your questions, did a fantastic job of it. I don't think I was able to design it to be as awesome as I wanted it to be. Today's is as awesome as I want it to be. Okay, so let's do this. The riddle for today will be nothing more or less. Oh, sorry. One thing I want to say. Thank you. Thank you very much, Dawn. I appreciate that. It's very kind of you. Thank you very much. I'm going to turn the chat off. It's nothing personal for that. Otherwise, I just won't be able to concentrate on things. I'm going to put the chat. No one. Seems mean when I say it that way, doesn't it? It really does. Okay. Actually, a couple of things, just kind of for the fun. First of all, make sure everybody that you have your notebook, some kind of notebook, some kind of piece of paper, something like that, nearby. There's going to be a lot of drawing on today's. And honestly, I say honestly as if I would lie to you about this. You have some colored pencils, have some markers, have some crayons, have some something. Grab some something, colored something, crayons, whatever you want. We're going to have a bunch of colors to draw for this, and the colors are actually going to be a really important part of what we're doing today. So make sure that you got some of those. There's another thing, actually just kind of an idea that I want to float with you guys, and it is this. I feel like I have this really cool opportunity, right? We all have this really cool opportunity to actually do this together for a year, and to like dig in right now for the long haul. And I'd like to get your thoughts, kids, parents, hamsters who are perhaps listening to this in the background, of what you think we could do with this group of people who's going to be learning all of the sciences together in 1 year's time. I'm kicking around the idea of starting a Facebook group for Science is Weird members, which is to say, y'all, a bunch of other people too, kind of around things. I might put up some other riddles or have some other sort of questions, some live lessons, like some games we can play, some science trivia games where you guys actually ask me questions and try to stump me on things. I'm thinking of kicking that around. If you like that idea or if you hate that idea, feel free to shoot me an email. You can actually email Angela at scienceisweird.com. She is the other half of my brain for this. Okay, so let's actually enough said. Let's actually begin this. So the question today will be nothing more or less than the following. Can you see light? Okay. As soon as we figure out the answer to that question, we will be ready to go, or we will be done. I will now turn on the, I will turn on the chat functionality. And it is on. I'll give you 30 seconds to go ahead and make your guesses for this. While you're doing that, I'm just going to connect into my other computer in case I get bumped out. And this computer has happened yesterday. All right, there we go. A few seconds left. That's funny. Oh, that's why. There we go. All right, so I'm seeing answers such as yes, yes, yes. Hi, Mr. Hendrickson. I think you can see light. All right, and I will tell you guys that, okay, stop for a second. I actually promise that the revelation that we have at the end of today's lesson is so delicious and delightful, and like getting from where we are right now to where that is going to be so amazing. But I might actually have to change the question ever so slightly, because of course you're right. Of course you're right. Of course you can see light. Of course you can see light. So let me modify this ever so. I say ever so slightly. It's going to be this massive modification. Let me delete all of this just in a second. Slightly darker color this time. Okay. How many colors, here we go, can you see? All right, now go ahead and take a crack at answering that particular question. No, it doesn't look cool. Never mind. I won't recolor that. How many colors can you see? Go ahead. I'll give you 30 seconds to answer that one. These are great answers, just so you guys know, even though they totally disagree with one another. Oh, man. Oh, yes, yes, yes. Take a few more seconds. All right. So I am seeing such answers as chat functionality. I wish I could do that faster. 5. Solana says 4. Dylan, the colors of the rainbow and all of the mix. I think I mean like all of the mixes between them. James suggests infinity. Shortly suggests 7 colors, specifically red, orange, yellow, green. I always get these wrong. Green, blue, indigo, violet. There you go. Roy G. Bit, very good. And Aiden suggests 99. All right. I will tell you. I won't even tell you that you guys are right or wrong. I think honestly you could argue for a lot of answers here. I will tell you that there's something hiding in plain sight. Literally hiding in plain sight. Okay, let me tell you guys this. How do I want to start this? Here, I'll give you guys this hint. Group these, get rid of this. All right, so in the year, I don't know. I think it wasn't actually the year 1666, but somewhere time after the year 1666, Isaac Newton, possibly the smartest human being ever to have graced the planet. Also a real weirdo, my sort of person. Isaac Newton, we'll go more into him. We do the eyeballs are weird class a few months from now. But Isaac Newton threw a piece of glass, a chunk of glass, in front of sunlight, and he said, oh, wow, look at these colors. There's these very specific colors that come out of here. And Isaac Newton said, well, let's count the colors. He actually did some things that I need to be careful. I don't want to get into right now because they're really cool. I want to talk about them later. He said, obviously there's red here, and there's also orange here, and there's yellow here, and there's green here, and there's blue here, and there's violet here, and then there's also indigo. And you're like, really? Is there indigo? Is that a thing that exists separately than the violet? Isn't that just like a combination of the blue over here and of the violet over here? Is that really its own thing? And Isaac Newton said, absolutely it is. It turns out that Isaac Newton, besides being the guy who oh gosh, what did he do? Who figured out what gravity was, besides being the guy who laid the groundwork to understanding how the planets move around the sun, besides being the guy who on a dare invented calculus, besides being the guy who figured out how light works, besides being the guy who figured out every flipping thing in the world, sometimes it feels like, he was also this mystic. And he thought that the number 7 contained these sort of like religious mystical meanings because of his sort of symbolic interpretations of the Old and New Testaments of the Bible. And so he said, there obviously must be 7 basic colors of light. And that is where indigo comes from, or at least why we have indigo as one of the Roy G. Biv, 7 official colors of light. So if you want, you can totally say 7. But what I want to suggest to you today is that there may be other colors of light. There may be, and of course, as some of us have said, it's not just like, here's 1 color, here's 2 colors, here's 3 colors. No. There are these subtle gradations between them, right? Like here is like red, and here is like orangey red, and here is reddish orange, and here is orangey reddish orange, and here's like straight up orange, and here's tangerine, and here is light orange, and here is yellow orange, and here is school bus, and here is straight up yellow, and here is green lime yellow, and here is like straight up lime, and here is, right, and we could like do that even smaller. So you could say that there is an infinite number of colors. I want to go beyond that though. What I want to ask you guys is, are there other colors? Are there colors that you can't see? Are there invisible colors of light? All right, I will now turn back on the chat functionality, get ready to type something in. If you'd actually like to like type something in right now into another program and just paste it in there, you can feel free to do that. That actually might be a good way for you to get your answers out more quickly. I always hit the wrong button every time. Settings, chat with everybody, and go. Are there invisible colors of light? Give you 30 seconds. If you can, who's Kennedy? If you can, go ahead and name some of them, if you think that there are. It's interesting, right? Like, when you look at your colors and your box of 64 Crayola crayons or whatever, maybe your parents were kind enough to buy you like a list of, or a box of like the 250, what was it, 128? What's the biggest Crayola box? Oh man, so cool. Like, you don't see invisible colors on there. I mean, what would they be? Would they be black? Would they be clear? All right, nice job all. I see a bunch, every time the wrong one. I'm gonna figure this out eventually. There's a button on here to make it faster. Maybe there's an add-on to Zoom I can buy somewhere. Okay. I'm seeing a couple different answers to this. First of all, yes, with like 17 different S's. UV rays and infrared, no, yes, 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 and radio. And then AV. I'm not sure what the AV means. Just right now, do you think that radio is a color? Radio? Honestly, radio being a color of light? Think about that. Think about that. Okay, yeah. But I'm wandering. That means I'm wandering in my mouth. Let me give you, hold on for a second. Let me tell you a story. Okay, so in the year, this is I just love the stories of old scientists who figured out lots of things. They're some of my favorite stories. I want to tell you the story of a guy who is just universally beloved in the early 1800s. I don't actually know what he looks like, so let's just say that he looks like this, with giant ears and no beard, and with kind of wispy little hair. Kind of a mop top right there of hair. Very good. This kind of a weird smile right there. This is William Herschel. William Herschel is, he is everywhere in the late 1700s and early 1800s when it comes to science. William Herschel figures out, well, he's actually the first person in all of human history to discover a new planet. Everybody knew about Mercury, everybody knew about Venus, everybody knew about Mars, everybody knew about Jupiter. I'll make it like this. And everybody, kind of like this too. Everybody knew about Saturn. They actually didn't know that it had rings for a really long time, but it totally has rings. This and like this. Okay. Everybody knew about all of those and had known about them. And I don't know, possibly every single human culture since like the Stone Age. What he did is he built this telescope that was like so big, he had to house it in a barn and like cut a hole in the roof of the barn and with his sister go out every night to like look at things, to look at stars. What he found was a new planet. It was bright green, bright kind of bluish green, and no one had ever noticed before. And he named this planet just like, obviously, like if you found a new planet, if you're the first person in human history to name a new planet, what would you call it? Obviously, he called it what you would call it, which is George. So he takes this new planet and he calls it George. Everybody else, he named it after the king, King George. If you've seen Hamilton or if you know anything about the American Revolution, King George the Third, I'm embarrassed, I should know this, was the King of England at the time, and he named it the King of England. And all of the other astronomers in the world said, that's a great, no, they did not say it's a great name. They hated that name. They said, we can't, you name planets after gods. You don't name them after kings, especially English kings. And so no one else called it George, only him. So instead, he had to call it Uranus. There's a pattern here, by the way. I shouldn't be talking about this because we're talking about light right now. I just can't help myself. Who is Mars's father? Sorry, Mars is the Roman version of the Greek god Ares. Who is his father? Well, his father was Zeus. Zeus is the Greek god. The Roman version of his name is Jupiter. Who was Zeus's father? His father was Kronos. Sorry. It's spelled a couple different ways. Was Kronos. Kronos is a god that exists in Greek. They don't really have exactly a Roman version of him, but the closest they could come up with was Saturn. So that's where Saturn comes from right there. Okay, did Kronos have a father? Yes, he did. His father was Uranos, the heavens, Greek word for the heavens. And so that is what the name they decided to settle on for this new planet, because it followed the pattern of naming it after they started giant. James, can you check on that and make sure that June's okay? Thank you. So I started a giant crash of lots of things falling and breaking. You know, honestly, I would say that it's never a dull moment here in the Hendrickson household. Okay. All right, everything, no screaming, no blood-curdling screams. So let's just assume that everything's going fantastic. To be a stay-at-home dad. Okay, so this is all to say that William Herschel is so cool. He's the first person in all of human history to figure out that there is another planet up there. But then the thing that he figures out after that is actually bigger than that. What he figures out after that is that, well, here, let me just tell the story because I'm terrible at this. Okay, so he is looking at this light spectrum. Spectrum just means like a rainbow, just means like a bunch of different things. If you have friends who are on the autism spectrum, right, it goes from like little to lots, right? A spectrum can also be like this, where it goes from red to purple or violet. He has one of these prisms, which means a chunk of something. Prisms out here, and he's seeing this rainbow, and he asks a question that maybe nobody else had ever asked before. He asks, I wonder, I mean, I know that like sunlight is hot. I wonder, are some of these colors hotter than others? So I'm gonna turn the thing back on right now. Go ahead and, yeah, it's the wrong button because I have to. I should just practice this. Go ahead right now and guess which of the colors is the hottest. Okay, tell me what crashed right now, but then I gotta go. I'm in class.
It was that picture of the hammer.
The picture of a hammer?
Yeah.
Oh, Mjolnir?
Yeah.
Oh, not Mjolnir. Oh. No. No.
And the glass crack.
No. It's our coolest painting. No.
The edge.
Oh. Thank you for ruining my week, James.
Hey.
No, I am thankful. I'm thankful. Here, but now leave. Let me do my class. Thank you. And thank you for telling me that. That did warrant telling me. Oh, we have this really cool painting of Mjolnir. It's Thor's hammer, not from the Avengers, but like from the Norse mythology. It's hanging on the wall and apparently just fell and crashed. You heard it. Okay, very good. Guesses include red, purple, either blue, indigo, or violet. Oh, the 80 was a mistake. James wants us to know. Shelley Lee. And violet, I think, is excellent. I'm going to turn off. Can I just turn it off faster? Solana thinks black. How can I turn this off faster with my laptop over here? I haven't thought this question before. Window, meeting, edit. I hope I don't hit anything bad that would destroy the world. Ha! Faster! I can totally do that faster now. Excellent, 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 excellent. Okay. So here's what he does. This is so cool. What I love about this guy, about William Herschel, is just his ability to ask a totally stupid question. It's just so obvious, right? Like, are any colors hotter than other colors? No one had ever asked that before. With your notebooks, one of the things I want you to be doing is just like writing down questions that you can think of that are stupid questions like that, stupid, simple questions, because it turns out that it's those stupid, simple questions that end up really helping. The more stupid questions right down the better. Okay, so here's what he did. He took a, what's the word? He took a thermometer and he lay it down on here. Like this was like on a table, right? He lay it down on here. This is like coming into the window. Lay it down in there. And then he put another thermometer, I don't know, like right here. And then he put another thermometer right here. And then just to make sure that he actually could like get like what the temperature of the room was, he put like a thermometer like way the heck over here and then like way the heck like over here or something. Okay, great. All right, so I'm going to make up these numbers. I don't even know if they had Fahrenheit back in this this time. So he measures this, and let's say that he finds that it is 70 degrees out in the house. Okay, 70 degrees out in both of those. He looks at the one in the purple light and finds that that, in fact, is 71 degrees. And that makes sense because, you know, like it's in the light. These other ones are just like in the house, but like this one is directly in the lights, and so it's warmer. This one, however, is like 72 degrees. And the one that's in the red is like 77 degrees. I'm making up these numbers. I really am making up these numbers, but there's somewhere about like that. He discovered that red light is hot light. Pretend that that is red light that is saying that right now. So you can actually test this out yourself. Like if you find red light, it will be, all else being equal, hotter than the other colors of light would be. But here's the next thing that happens, and this is the thing that changes everything. This is the thing where he makes a discovery that is bigger, is literally bigger than discovering another planet. What he does is he goes to lunch. He leaves his room, his laboratory, whatever. He leaves it, and then he comes back a couple hours later. And a couple hours later, the sun has changed where it is. No longer is it coming from over here. Now it's coming from over here. And the light is coming through like this. Here, let me actually draw that rainbow. So it's like, here is the red, and here is the orange, and here's the yellow, and here's, you get the idea. I guess I probably don't even need to do this. But I will because I can't stop myself. And what he finds is that he hasn't actually moved here. I'm keeping out indigo because I don't care about you, indigo. What he finds is that this thermometer, its temperature has changed. No longer, it's still in the dark, totally still in the dark, but no longer is it 70. Now, this thermometer is like 85 degrees. Even though it's in this black region of light right here. Herschel thought about this, and what he realized is that he had just discovered a new type of light. He had discovered invisible light. He had to name it something. And so he put on his creativity thinking hats. He didn't, I'm making that up. And what he called it, he said, well, it's below the color red, right, on the spectrum, on the rainbow there. So what I'm going to call it is, drum roll please. No, seriously, you can do drum roll at home. That's okay. You can do drum roll at home. I'm going to call it below red. Except I'm going to call it that in Latin, so I sound cool. In Latin, below is infra. So I can call it infrared light. Maybe there's a little dash there that we use. I kind of forget the way we spell that. It turns out that there are, this is a really pretty picture that we all drawn. Congratulations, everyone. So it turns out that there are not just 7 colors of light. There are our ordinary 7 colors of visible light. And then there also is infrared. Infrared right here. And actually I'm going to, I suppose, draw underneath this our red and our orange and our yellow and our James and June, I can hear you. This, and just to be polite to the smartest man to ever live, I'll put indigo in there, and then violet. Okay, great. So it turns out that the colors that you can see, the light that you can see is not all the light that there is. Okay, interesting question. What the heck would the world look like? How do I do this? What the heck would the world look like if you could actually see all this infrared? It turns out that there are animals that can actually see infrared lights. Among them are rattlesnakes and other types of pit vipers. I am turning the chat on. Go ahead and test that out to see if that works. Here's what I want you guys to fix. Here's what I ask you guys. If you could see an infrared, what would the world look like? Let's say that you could see all the colors you could see now, except you could also see this other like bunch of different colors that your brain can't even think about because we've never seen those colors before. Like what would look different? Like if you looked at this book, would this book look any different than it currently looks? If you looked at a flashlight, would a flashlight look any different than it looks? What would look different? Can I show you something actually? My kids and my wife, for my birthday, gave me this. This is an infrared camera. It just actually plugs into the bottom of my phone. So here is my phone and here is this, and I plug it in, and then I have this app on here, and then I can, well here, actually, I took some pictures earlier. Let me show you these pictures. See if you can guess what these pictures are of. Any guess what this is? It is a human. Specifically, it's my son. What's that in front of him? Dylan, Satan is spelled with 2 A's. And I'm going to call that a... I do a lot of religious references in class because that's what really interests me, and I want you guys to know about that, but I'd actually like you guys to limit the yelling Satan in class, at least not for a laugh. If you think I'm actually talking about the notion of the devil, feel free to bring it up, but otherwise I'm going to say no to that. No, he's not playing video games. Here, I'll give you another guess, another hint. Or, yeah, what's this? It is, in fact, a cat. The app that I have has a couple different ways of coloring it. I like better the ones that are just black and white. Here, actually, let me show you this. Oh, take a look at this. This is actually kind of fun. It also does videos. Very bad videos, but videos. What I want you to think about is, why are some parts of my cat brighter than other parts? Do you see that? Look at her eyes. Look at her nose. What the heck? What the heck? Why are her eyes so bright? Why is her nose so black, so dark? All right. Give you another hint. This one coded blue for some reason here. Just this one, it didn't. Why are my eyes dark in this picture? Oh, and yes, this is a picture of me. Note also how my clothes are dark. And yes, you can tell that I'm wearing clothes even from infrared light, even from only infrared light. You can see that I'm wearing clothes. Why is that? James suggests that they're glasses. Do you guys think that they're sunglasses or regular glasses? Dawn guesses sunglasses. I'll tell you that they're not. These are just me. This is just me wearing my regular glasses here. It turns out that glasses block infrared light. And I bet you know that if you've ever been inside of a car on a sunny day. It doesn't even need to be a hot day. But if you're inside a car, like even in winter on a sunny day, you know what happens inside the car, right? I'll tell it to you without using the word that you want me to use. The light enters as just regular visible light. And then it hits you and it hits the seats and whatever, and then it turns into infrared light. And the infrared light can't actually go back out through the windows. It bounces off the windows, gets stuck inside of the windows, and so the car gets really hot inside. Let me give you another thing. Yeah, the picture of the cats. I actually have no idea what this is a picture of. Look at her. Tiger, tiger, burning bright in the forests of the night. What immortal hand or eye can frame thy fearful symmetry? In what distant deeps your skies burned the fire of thine eyes? Look at the fire of her eyes there. Oh, so cool. Look at my son's fingers. Sorry, I haven't watched that video before. That's great. Picture there, picture there, picture there. Yeah. Where are the other ones that I have? Oh, right here. This is my daughter. Take a look at what she's doing here. Take a look at her eyes. Again, her eyes are glowing. Her mouth is glowing. Her neck is glowing. Why is that? If you could see infrared light with your regular eyeballs, you would actually get to see this. But you're blind to this. You can't see these things. All right. What a lot of you guys are guessing is totally correct. Yes, exactly, Aiden. Heat. Infrared light is actually heat. Let me take that and turn that around. Heat is actually light. Okay, give me a thumbs up. Sorry, it's a seminar thing. I asked people to give me thumbs up or thumbs up. You guys tell me right now, do you think that this is actually true, this idea that heat is a type of light? Heat is just a type of light. Tell me yes or no to that. I will tell you guys the answer to this question. Sometimes it really helps us to actually define heat as atoms jiggling together, and other times it helps us define light as the light that gets shut off. It turns out that those two things end up kind of being the same thing. We'll talk more about that, I hope, at some later point. But yeah, for right now, yeah. All heat is, when you feel heat, it's just light. When I was a kid, I saw this advertised on television. Oh, where is this? This and this, and oh, where are you? This. An easy bake oven. oven for kids to use. James says photons versus matter waves. More complicated than that, but yeah, we'll see more about that actually next week on Tuesday. I saw this as a kid, and this advertised that you could like bake some actual kids' candies or cupcakes or whatever using a light bulb. And I thought, that's dumb. Obviously, you can't bake something using a light bulb. And then it took me years to realize. Oh, sorry, we're working on our new website. It's very exciting right now. Take a look at this. Ooh, ooh, ah, ooh, ah, ooh, ah. It's gonna look so cool. Ooh, ah. Okay, sorry. Oven turned on. No, not by itself, for heaven's sakes. It took me a long time to realize that like an oven, like the kind of oven that you roast things in, all it is a flashlight. It's just a flashlight that's specifically designed to give off more infrared light than visible light. Although look, like it also gives off visible light, right? Whenever you cook, you are cooking with lights. I think that's true. Okay, so the original question is how many, what did I even ask? How did I ask it? How many types, how many colors are there? We have at least, what, 7, original 7 plus 1 more of the infrared colors. We have at least 8. In fact, let's just simplify that. We have all the visible colors. It's one type of color. And then we have infrared. But it turns out that's not all of the colors. Oh my gosh, you have 14 minutes left. This is terrible. I have so much more to show you. Fast forward like 2 years after 1800, like 1802, 1803, everyone in Europe was talking about Herschel's discovery. And there's one guy who thinks, hey, you know what I should do? I should take a thermometer and I should stick it on the other end of the spectrum and see if it is cooler on the other side of the spectrum, like right next to the violets. Turns out he's totally wrong. But after he did that, he failed at that. He tried something different. He put a photographic plate on there. Photographic plate, basically a piece of paper that has some chemicals sprayed on it, that when light hits it, it turns a certain color. This is how photographs used to be made before before computers kind of took over the photography business. Just imagine that there is a piece of paper that has chemicals sprayed on it, that when you expose it to light, the paper then turns color. The chemicals turn color. He put one of those over, just a second. He put one of these over here. Oops, let me draw this as white. Actually, and then let me hide all of that stuff. So he put a color plate right here. Yep, it changed color, I put one right here. Yep, it changed color, I put one right here. It changed color, and actually this one changed color faster than any of the other ones did. And he realized, oh my gosh, I have found a new type of light. What should he call this light? He knew that it was some kind of light, like his eyes couldn't see it, his brain couldn't make sense of it. But he knew that this light was beyond purple. So he got super creative, and what he decided to call it was beyond purple. Or, just use fancy words, ultraviolet, and that's all that means is beyond purple. And it turns out, we've now found out, that there's lots of animals that can actually see in ultraviolet, usually insects. And so it turns out that there are flowers, that if you look at the flower through, just like with your own pathetic human eyes, you don't see most of the patterns. You only see them if you have insect eyes. The petals know that the patterns are there. The bees and the ants and whatever know the patterns are there. It's just us humans who walk by and have no idea what's going on, because it turns out there's nothing special about the colors that we have, that we can see. All of the colors are equal in nature's eyes. All right, so it turns out that it's not just, okay, now I need to actually try to shrink these things down. It is not just visible lights on the one side and infrared on the other. It is infrared, visible light, and, go ahead and draw this. Oops, ultraviolet lights. What color does ultraviolet light actually look like? You can't know that unless you're a bee. We just have no idea. We are blind to ultraviolet light. Okay, so give me a thumbs up or a thumbs down. Sorry, that's not a thing that we do. Sorry, I'm using my seminars. Go ahead and tell me yes or no really quickly. Do you think that that is all the colors of light? And in fact, the guesses that we have so far are in fact correct. These are not the only colors of light. Take a look at this. In World War II, between World War I and World War II. Wait, hold on. Do I want to do that one yet? Yeah. Between World War I and World War II, scientists found that there's a way of making another color of light, another color that we, with our puny human eyes and our puny human brains, cannot see. And this, if you made a big, here, I'll even show you. If you took a giant flashlight of this and you shined this invisible light in the air, it would light up airplanes. It could light up airplanes hundreds of miles away. And so you could see if the airplanes were coming. And you couldn't see it with your human eyes, but you could see it with like a special camera that they also designed to be able to see this special kind of light. And they called this kind of light radar. They actually, it's interesting, they called it two different things. They called it radar on the one hand, and then it turns out that there's this guy who near the end, he was a researcher, he was an engineer, he worked in the Navy, I believe. He enlisted in World War II in the Navy, and he helped the Navy make better technology. And he worked, near the end of the war, he worked for a company named Raytheon. And Raytheon was making military technology. And they were testing out radar, and this guy, what was his name again? Percy Spencer. Percy Spencer, he was standing next to one of the radar machines, and then he felt something wet in his pocket. And he realized that he had a chocolate bar in his pocket, and the chocolate bar was melting, it was just like totally melting, like I'm guessing seeping through his nice white pants. Probably everyone laughed at him, but he went, And he realized that this radar technology, this new kind of light that human eyes could not see because we are blind to it, could be used to heat food. And, radar. And so what we now call this also is microwave lights. Microwave is another color of light, or maybe we should even say not a color of light. Maybe all of these things are not like a color of light, but all these things are like 1,000 different colors of light, right? Like if we say there's like 7 different colors in like side of here, we should maybe say there's at least like 7 different colors or 100 different colors or something like that in each of these. And like bees can like tell the difference between all these ultraviolets, and snakes can tell the difference between all these infrareds. And I don't know, aliens can tell the difference between all of these microwave radar things, but we can't with our puny human eyes. It turns out that, I'm just rushing through this because, oh my gosh, 7 minutes left. Why did I think 15 minutes would be a good idea? I do not know. Just a second, let me include this also in here. Okay, there. It turns out that this is not all the types of lights either, because it turns out that there is, even beneath radar, one other, and only one other type of light. And that is, I'll give you a hint. This. When you are in your car radio is a camera that can see light, a certain kind of light, that you cannot see. In fact, if you are in your house and you have a, if you have a radio in your house right now, hold on, I'm getting ahead of myself. These, first of all, go ahead and draw this. Make sure you're drawing this, because this picture actually ends up being one of the most important pictures in all of science. That there is this other series of colors of light, and we just call them radio lights. If you have ever seen, insert a photo, insert specifically this photo. Have you seen one of these before? A big radio tower. They can look a bunch of different radio towers. There's a bunch of different ways for radio towers to look. Right, here's some of them, blah, 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 blah. What are these things? These things are giant light bulbs. That's all they are. They're giant light bulbs. And they have different colors. In fact, they shine in all sorts of different colors at the same time. Or I shouldn't even say at the same time. It's like, it'll be like green, blue, greenish blue, yellow, yellow, green, blue, red, red, purple, red, orange, orange, blue, blue, orange, yellow. And it does it like millions of times a second. If you could see these things, you'd look at this and go, wow, what the heck is happening here? And it's so bright that the light shines for miles and miles and miles, tens and dozens and maybe hundreds of miles around. And it's so powerful, it can go, let me not say powerful. Let me just say that it has the ability to go right through walls. Like right now in your house, there is this light that is going through your walls. You can't see it. You can't see it at all. Your puny human eye. Why do I keep making fun of your puny human eyes? I don't know, because I like to make fun of you. Your human eyes are not enough to see this stuff, but there's light everywhere. Like, you should be able to see this thing through your wall right now, glowing up, like wherever the nearest one is. If you look in that direction, you should see it glowing through your wall. But you don't. You don't see it at all because you can't see these things. You just can't see these things. It's ridiculous, really. It's not even 4 minutes left. Oh my gosh, race the bitter end. That's not even all the types of light. As some of you guys are saying, actually, on one of these things, what's the word? On the chat right now. Hey, I just want to thank you guys. You guys are actually doing a really good job of like self-policing the chat and making sure that nothing inappropriate happens on there. I think like keep the chat open for longer, kind of unwatched, if I have the trust for you guys that nothing inappropriate is being shared on there. The Satan comment before was like kind of farther, whatever. We'll just say kind of as a general rule, if anyone abuses the chat functionality and starts talking about inappropriate things, we will deny your ability to use chat for a little while. And if it gets too bad, then we might have to kick you out of class. I trust that won't have to happen, but we'll just kind of have that in the books. Okay, cool. There are other types of light too. This guy, Wilhelm Röntgen, and I don't know what even year. He was experimenting with putting electrical currents, basically just electricity, through a empty tube. And when I say it was empty, I mean literally there's no air inside of it. It was an empty tube. It was a vacuum tube. Putting it through there, and he found that there was this plate on the other side of his room, his laboratory, that started glowing. Even though he had covered this vacuum tubey thing, he had covered it in a box or in cardboard or something. So there's no way that light should be getting out, and you couldn't like see the light in there. But on the other side of his house, this plate that was covered in, I don't know, some sort of weird atom. What was it? I forget what it was. Barium. It was glowing these eerie colors. And like, what the heck is going on? And he realized, oh my gosh, I've discovered some sort of new invisible form of light. And he said, what are these rays? They are mystery rays. And in math, how you write a mystery is X. So he called them X-rays. He then invited his wife down to see this, and he actually put a photographic plate, like a piece of film or whatever, on the wall, and he had her hold her hands up to this, and here's the picture that she saw when he developed the film. This is exactly the picture that she saw, and she screamed. She said, "I have seen my death!" And she was the first person in human history to see her own skeleton. Up until this point, the only way you could see your skeleton was if you were dead, which means that you probably couldn't see it, or been ripped open by a pack of wolves or something like that and still being barely alive. Wow, that got dark really fast. Anyway, she freaked out. And now we use X-rays to do all sorts of things. So, like you've probably been to the dentist before, and you've probably had the dentist take X-ray dentist machine. You probably have a dentist take x-rays of your teeth. And I don't know, my dentist, it looks something like this up there. All this is a flashlight. It is a flashlight that pushes out invisible light. And then on the other side, the thing they put next to your head, that is a camera. That's actually a camera that sort of receives the light that you can't see, but it can see because it's specially made to do that. There is, oh gosh, look at this. It's already 50 past the hour. There is exactly one other type of light. And that type of light is called, well, we call it doesn't know what to call itself. We call it, one word here, gamma rays. We'll talk more about gamma rays in the future, specifically next Thursday, when we talk about what is the most dangerous type of light. For right now, the only thing that you need to know about it is gamma rays are historically the secret for becoming the Incredible Hulk. Scientist Bruce Banner should have been killed when he was caught out in the open near a nuclear explosion. But instead, mysterious gamma rays changed him forever. Now, in times of stress, he undergoes an uncontrolled change. He becomes the most powerful monster on Earth. Bruce Banner becomes the Incredible Hulk. And it's all because of the gamma rays. Okay, so just to go back and ask our original question, which I don't know, it was like 15 minutes ago. Okay, remember, how many colors can you see? Or the way that we had originally asked the question, which was, can you see lights? Think about it neither of those ways. The answer here, go ahead and guess the answer right now. I'll give you 20 seconds before I show you my answer, which you know what, honestly, maybe you should disagree with. So I'm seeing a lot of yeses. Yes, of course you can see lights. Guys, I think that you're not seeing the bigger picture here. I'm not going to cross this off with red, but I'm going to cross this off with yellow. It's not wrong, but it's not the important truth of the universe. The important truth of the universe, and here I'm going to draw this cartoon, right, where I'm showing this cartoon, which is already in the deep dive that's been sent to you. It's in your parents' inboxes, which you should copy down into your notebook. Can you see lights? I think the only full answer to this could be no. Because, well, only barely. All of the colors that you can see would be just one key in a line of 314 pianos. We've been drawing this as if the visible light spectrum was like about the same size as the infrared or the X-rays or the radio waves or whatever. It's not. If you had a piano and you took just one key of that and you colored it, you painted very fine lines of red and orange and yellow and green and blue and indigo and violet on that one key, you would need to have 314 pianos. This is not a picture of 314 pianos. That would take too long for me to draw. 314 pianos to show you all of the other colors. You can see 0.0035% of all of the colors in the universe, which I just gotta say is pathetic. Honestly, like you should be doing better. Try harder, people. Try harder to see the real colors. Everyone, thank you guys very much. It's been a pleasure. Quick notes. Your parents are invited. Actually, any other adults that you, shortly I can, in the, what's the word? It's in the deep dive, actually. It's already in your father's email inbox. Something. Your parents are invited tonight. I'm actually doing a special thing. I only do this once a month. It will be at 7 p.m. Central. It'll be at 5 p.m. Pacific. So wherever you live, you adjust your time there. 0.0035. There you go. The two of you guys would actually really get along really well together, just so you guys know. I'm doing a science lesson that's just for adults. It's not this webinar format, it's the seminar format where they actually show their faces and I ask the questions really quick and they actually participate in the lesson. They talk back and forth to me as part of it. And we are taking one single riddle, and that riddle will be, why do you have lungs? I know that you guys think that, I'm turning off the chat for a second, that you guys think that you have lungs in order to breathe. And of course, lungs allow you to breathe. They're great. Don't get rid of your lungs. However, the original reason that your ancestors had lungs had nothing to do with breathing. What was it that lungs were supposed to do before animals started using them for breathing? What was the first kind of animal to get lungs? Why did they have lungs? And what is the secret function of your lungs that you can use even today? In fact, frankly, you probably have used even this summer that we never think about when we talk about lungs. Your parents are invited to this. If they're interested in this, they can actually, I think, go to the website. Yeah, maybe not. It's called Science. I think there's a page called Science and Beer. They don't need to drink beer as part of it. I probably will drink beer as part of it. Usually do. Something. They can sign up for it by sending an email to Angela@sciencesweird.com. She will send the Zoom link for them for this evening. It's a lot of fun. You can also recommend it to any of your friends' parents, but not actually to your friends themselves. But it's a good way of sort of figuring out what the heck is going on in these Science is Weird classes. Everyone, thank you very, very much. I'll see you guys next Tuesday. Good luck practicing your, what's the phrase, your trivia questions for this week. I did a bad thing. I didn't actually quiz you guys on your trivia questions for today. I'm going to try to do that in the future. Maybe if we come in early, if you guys want to log in early, I will ask you guys trivia questions. Yeah. So look forward to that. Okay. Toodles, everyone. Thanks.